All right, design the controls for a garage door. The door needs to operate both up and down with a stop button. When traveling down, if something passes under the door needs to stop and move up. The door should stop automatically when it reaches its upper and lower limits. An e-stop circuit should be used to stop the door in an emergency. If the e-stop is pushed, a red light and a horn should energize.
All right, so we have the diagram drawn out. Let's go over it. So of course, here we have our control voltage coming in. It's going to be fused through this fuse. And as wire number 1 gets tapped in, it's going to go to our first component, our e-stop push button. Now this e-stop here is going to be dual block. So there's one normally set of open close contact behind that, and another set of contact which is normally open, used down here on this rung. Coming through our e-stop is wire number 2. It's going to parallel to our stop push button, and we have another wire that's going to parallel to our photo eye. And this is going to energize our photo eye so that whenever something blocks the photo eye, if the photo eye is then in turn going to switch a signal to send 24 volts over to our control relay, CR1. Then we have power going through our stop push button to our up push button, and wire number 3 is then going to parallel out to a set of normally open contact, auxiliary contact from our forward or our up contactor. So these are forward and reversing contactors. You can see this here. This symbol here is our mechanical interlock. So this tells us that they are mechanically interlocked. So when this contactor is going up, it's mechanically interlocked so that the reverse contactor cannot engage, and vice versa. So here we have power that's going to latch in to wire number 4. We're using a set of normally closed contact from this contactor. The auxiliary contact that is on this contactor is going to electrically interlock. So if this is on, this opens so that we can go up. Same down here. If the forward contactor is engaged, this opens up so that we can no longer energize this. To our limit switch, our upper limit switch, it's a normally closed upper limit switch, and from wire number 6 then sends power to our up or forward contactor. Coming out from a contactor is wire number 7, goes through a set of normally closed contacts on our overload relay. In the event it overloads, the overload relay trips, this is going to open up. It cuts off our new return side to our negative, and we no longer have control power. Well, we will have the 24 volt side, but we won't be able to complete this circuit because we are cut off from our return side or the negative side. Wire number 0 is our common on all the rungs to go back to our 0 volts DC or our negative side. And then we have wire number 3 paralleling out to a set of normally open contacts from our time on delay relay. Down to our down push button. This is going to be our latch. Same as up here. This is going to be our latching circuit to keep this energized after we depress the up push button. Wire number 3 continues down to a set of contacts from our photo eye. When the photo eye sees something where it triggers the photo eye, it's going to close this up here to allow a path or a continuity path for a 24 volt signal to go through this time off delay set of contact to energize our CR1. This is our latching circuit for CR1. CR1 uses a set of normally open contacts from itself to latch itself in. CR1 also uses another set of normally open contacts to energize our time on delay relay. So let's go ahead and see how this circuit works in action. So if you imagine the garage door, let's say the garage door is in the down position right now. So it's fully down. This lower limits switch is open, because when it's fully in the down position, this makes the switch so it's open. We can no longer go down. You can press down all you want. With this switch being open, we cannot energize our reverse contactor or the down. So we only have one option, is to go up. So we go ahead, we press up. We are then gonna close. We are then gonna close this contact. So this closes momentarily. Our 24 volt signal then goes through here. The reverse contactor is not engaged, so this contact is closed. The upper limit switch is not made, so this remains closed. So as at this moment, we now have 24 volts at our coil. Overload is not tripped, so our coil engages as we press down. Once we release this, since this is energized, it now closes this set of contact right here. So that closes. This opens back up. So now this opens back up. 24 volts can no longer go through this path. But now 24 volts can take this direction here through this closed contact. And it's going to keep this coil energized, pulling in our contactor. So now our garage door is going to start going up. It's going to go all the way up until it makes this limit switch. It's going to make the limit switch, which in turn that is going to break it. So now this limit switch is open. Now this is open. That stops at 24 volts to here. The contactor coil is no longer energized. So when this de-energizes, this opens back up. So this is open back up. This is de-energized. While this was energized, down here is open. So while this was energized, this is open down here. And that's to interlock them electrically so that you can't press down on it. You can press down while this is the conveyor, the garage door is going up, but it will not go down because this is open. So now the garage door is all the way in the up position. So now let's bring it down. We go ahead and we click down. All we got to do is press it one time. It's going to momentarily make that. 24 volts then makes his way over. The forward contactor is not energized, so this contact remains closed. CR1 is not energized at the moment, so this remains closed. The lower limit switch is not made because the conveyor garage door is still up, trying to make its way back down. So now we have 24 volts going to a reversing contactor. Overload is not tripped. So this is now energized. Wire 11 also parallels down to a time off delay relay. As soon as this time off delay relay receives that 24 volt signal, it's going to close this contact down here. So this time off, normally open, time off delay contact is now closed. It immediately closes. But the controls relay, CR1, will not be energized because the photo eye needs to see something blocking it before it can energize or before this will switch close. So now this is energized. So the garage door is coming down, and it's either going to come all the way down and make this limit switch, the lower limit switch, and break open to stop the reversing contactor so that when it comes all the way fully down, it stops, it makes the switch, it opens up, it stops, cuts power to the reversing contactor, garage door stops. The time off delay relay then starts timing. Once this stops, and after 5 seconds, this will open back up. But let's say that the photo eye senses something as the garage door is coming down. So the garage door is lowering, and somebody or something comes in between it. The photo eye then makes. The photo eye switch is closed because it senses that there's something there, and that's to prevent the door from coming down on whatever object that is on. So now the photo eye closes. Now we have 24 volts switching over to this time off delay set of contact. Now this is closed. So that's going to trigger CR1 to energize. And now CR1 energizes. It's then going to close this set of contact down here. It's going to close here. And it's going to open up here. So somebody walks through, the photo eye triggers. It triggers CR1. CR1 closes this latching circuit to latch itself in. It also closes this circuit and sends 24 volts to our time on delay relay. It opens this circuit. It stops the reversing contactor. So as the garage door is lowering, it opens this, it stops it. It is no longer reversing or no longer coming down. The garage door no longer comes down. And then it starts this time on delay relay. After 3 seconds, it's then going to close this set of contact up here. This then closes. And it's going to send 24 volts signal to our up. Now this limit switch here is closed again because as we came down, as the garage door come down, this limit switch closes again. So now we have this path that's going to close here, send 24 volts to our up contactor, and the garage door is going to start raising up. So it came down, it sensed something, it stopped in its track, and now it's reversing, it's going back up in the up direction until it makes that upper limit switch, and then it stops. In the meantime, since we know this is no longer energized, after 5 seconds, this opens back up. So this opens back up, it cuts power to our CR1, opens this back up, opens this back up, it cuts off power to our time on delay relay. This opens back up, and now we should be, this closes back up. So now we should be able to, once it makes this all the way up to the upper limit switch on the forward, and its garage door is all the way back up, we can then press the down button and repeat that sequence again, and the garage door will start coming back down. Unless something triggers the photo eye again. If whatever object is still blocking that photo eye, the garage door will try to come down. As soon as it comes down, this is going to trigger CR1, cuts this again. It can no longer come down. It's going to have to go back up again. That's the safety of that. And then the e-stop, if we would happen to press the e-stop, it's going to cut power to everything here. So nothing here would work. The photo eye will no longer work because it won't have the power to be energized. This contact here, normally open contact here, will make. And now we'll have 24 volts. Coming over to energize a red light. So now our red light will turn on, and in parallel to that red light, we will have a horn. So if the e-stop is hit, it's going to send 24 volts through this normally open contact, which is now closed. Turn on the red light and turn on a horn to indicate that the e-stop has been pressed. So there we have it. Until next time, deuces.